Hi, this is Prashant from MIT Media Lab. I will be presenting our work on learning domain adapted persona representation using pre-trained BERT model and external memory. We call it DAPPER. With increasing human-machine hybrid technologies, the real-world interactions with AI systems are often stilted. This shortcoming can be attributed to the lack of shared common knowledge about how people will act, communicate, and react under different circumstances. Several studies in the field of psychologies have established the role of personas in governing how people process information, attend to and interpret life experiences, and respond to social situations. Towards endowing machines with such persona modeling, we see their application in different areas such as conversational agents, social media behavior mining, and narrative intelligence. In each of these domains, personas are often defined and treated differently. Prior work have used different framings of persona to suit their requirements. As one can see, for some of the conversational agents' work, persona is defined based on the background information and speaker style. In some other studies, persona is defined by the profile with character descriptions containing interests, likes, and dislikes. If we take the application of behavioral mining, persona is defined using different trait theoretical models like Meyer-Briggs type indicator given as MBTI, or in some other work as Big Five traits model in a work by Goldbeck. From understanding it to using it for recommendation systems, personas can play a really significant role. In narrative intelligence domain, understanding the narrative can be done through the perspectives of the story characters. It is important to analyze the characters individually as well. This applies not only to literary characters but film characters as reflected in the work by Chu and Baman, who use character tropes and archetypes as a means of defining persona of the movie characters. Therefore, in this work, we define persona as the sum total of mental, emotional, and social characteristics of an individual as explained by Soloff in 1985. This broad definition, while basing on theoretical foundation, allows us to learn persona embeddings from annotated text that span across multiple domains and social contexts. Therefore, for this work, we use different corpus and data sets that we gather from different domains and use it for our purpose of modeling. Personal stories or reflection explain important parts of one's important personality, including their goals and values. For our purpose, we make use of personal essays originally from Pennebecker's work. Students were asked to write their personal life stories, and those who produced such stories were assessed based on Big Five questionnaires. To obtain labels from the self assessment, Z scores were computed, and then the resulting scores were discretized to categories. The next comes the forum posts corpus, which contains 16 personality types based on Jung's theory of psychological types. These were recognized as useful reference points to understand one's personality. We collect text corpus from a discussion forum called Personality Cafe, which has dedicated communities for each of the 16 personality types. The members of these communities generally self identify with the corresponding personality type and post various forms of text, including those written in the stream of consciousness style. To obtain these posts, we crawl specific sections of the forum related to each personality type and filter posts that are too short and replace explicit mentions of the personality type in the text with markers. Finally, in the context of fiction, we collect movie dialogue corpus, which is also based on IMDb dialogue snippet corpus. Character tropes are defined as aspects of story that conveys information about a character, including their role, personality, motivations, and perceived behavior. Using IMDb dialogue snippet corpus obtained by Chu, which contains utterances of characters in movies based on CMU's movie summaries dataset. Each character is associated with one of the 72 different trope labels, and then there is a domain specific knowledge obtained from TV Tropes website. This is a wiki that collects document descriptions about plot convention and devices and also contains useful notes describing MBTI and Big Five personality traits. And then we place our work on the basis that the MBTI and the Big Five personality traits are correlated. This has been studied earlier as well. We This is the premise on which we place our modeling work. Finally, here on the left, we can find samples of text data from each of the different domains. And then on the right, we find the data set statistics, basically containing the size and the categories of each of the different data sets that we have aggregated and collected. Therefore, we propose a model called DAPPER to learn a domain-adapted persona embedding that promotes positive knowledge transfer across multiple text domains, which includes movie dialogues, forum discussion posts, or the personal life stories or essays. Towards this goal, we use a pre-trained BERT model to extract rich semantic features from text and fine-tune them by introducing adaptive knowledge transformer, which serves as adaptive layers on the top of the representations obtained from the BERT model. These adaptive layers enrich and sharpen the representations with domain-related personal knowledge. So the first component is going to be the input processor or the input processing module. Here, for the personal essays and the forum post, we introduce a new token called CLS token at the beginning of each sentence in the essay or the post, which accumulates the features of the tokens following it. For the dialogue corpus, the CLS token again separates each dialogue snippet, while the characters, sentences, and the additional context are separated by a SEP token. Finally, we introduce segment level embeddings, which alternate between two consecutive sentences or dialogue snippets. Therefore, our input document is passed to the input processing module, which outputs a document representation augmented with special tokens like CLS and SEP token, and then processed with the segment and the position embeddings. The processed input is then passed to the pre-trained BERT model. We obtain contextualized embeddings related to each token in the processed input document. We then integrate the external memory module with a transformer architecture and refer it as an adaptive knowledge transformer. This component aids to create a persistent latent embeddings related to persona categories and further accumulate more knowledge as we process data from new domains. We conceptualize this component to be composed of a key value memory store, KVMS, that specifically facilitates adaptivity to new domains, and the transformer-based adaptive layers that attends over the contents of the memory to enrich the representation and sharpen it further to contain the persona-related domain knowledge. So as you can see, the KVMS module consists of a mutable key matrix that accumulates persona-related knowledge across multiple domains, and a non-updatable value matrix containing a learnable persona category embedding. The key matrix is initialized with representations of text descriptions of the character tropes, MBTI, and the Big Five traits model collected from the TV Tropes Wiki. Our transformer-based adaptive layers contain an additional sublayer to integrate with the persona relevant domain knowledge into the contextual representation obtained from the encoder from the previous step. And we refer to this sublayer as knowledge attention, as is highlighted here in the diagram. This is the fine-tuned part of the model, which is done using domain-specific categories based on a supervised classification objective. Our knowledge attention mechanism identifies the most correlated and the relevant knowledge from the KVMS component with respect to the input document embeddings. We stack such adaptive layers on top of each other and output the final layer from the adaptive layers to obtain the final domain adapted persona representation. Intuitively, accumulation of persona related knowledge can enhance the overall quality of the learned persona embeddings. Therefore, we perform a memory update operation on selective rows in the key matrix based on the persona related features derived from the input document and its corresponding ground truth persona labels. We only update those rows which contain the ground truth persona label that matches with the input document. We find the preliminary experiments that the mean CLS token embedding serves as an effective alternative to computing an average embedding over the tokens in the input document. So we design our experiments to study the following research questions. So the first question is, how well does our DAPPER model perform in comparison to other baselines and its variants? Since we collect data sets from different domains, we also compare our model performance to domain-specific baseline methods. For example, for the personal essays corpus, a method like AFTOVEC was used, which contains word embeddings enriched with effective interpretations. And then for the movie dialogue corpus, AMN or the attentive memory networks were used earlier. And then we use a transformer based model, which is a non pre trained model trained from scratch without additional domain knowledge, which is given as TTS. And then a similar model to our model, which is BERT based, but the difference is the GRU based adaptive layers with a persona classification task. And then the final one is the DAPPER model, which is the full model. And then we also experimented with variance with a suffix minus k, which indicates without the knowledge attention module. We report the F1 scores for the movie dialogue and the forum corpus, whereas we report the accuracy scores to be consistent with the prior work. And we find a significant improvement using the DAPPER model, which is like a 14.5% improvement on dialogue corpus and an 8% improvement on the personal essays corpus. Even the transformer-based adaptive layers have been really useful in comparison with the recurrent-based models, and it has given like 6.1% improvement with knowledge attention and 4.2 without knowledge attention. Therefore, knowledge attention plays a significant role in all these different corpuses. We would like to analyze if we can apply a model to domains with limited data and see how quickly it can adapt to the new domain. So the question is the model capable of adapting to new domains with limited labeled data? We run our model in adapt mode, which simulates low data regimes where we restrain the amount of training data for only one of the domains while retain the complete data set for the remaining domains. We find that by doing it, our DAPPER model is able to learn general purpose persona embeddings that can adapt to low data settings. It achieves a really good performance on new domain in less than 40% of the training data. Finally, we would like to verify if the learned persona embeddings are transferable to a downstream task. Since a DAPPER model learns persona embeddings from different forms of text, we deem it fit to explore how well our persona model can transfer knowledge to a hate speech detection task involving text from different domain, which in our case is Twitter. So the question is, are the learned persona embeddings transferable to a downstream hate speech detection task? So we take advantage of the models and datasets introduced earlier, interpretable multimodal hate speech detection work. In their work, they train a bidirectional GRU character-based model with an attention mechanism. This is referred to as BCA. Instead of merely using text features, the previous work also incorporated socio-cultural features based on demographic and network features using multimodal fusion techniques. Now, we integrate the persona embeddings obtained from our model and perform early and late fusion techniques in the architecture of the BCA model. We note that the combination of all extracted features, including our persona features, leads to a marked improvement in the prediction performance as indicated in the graph below. And even more so when the persona embeddings are added. Early fusion works much better than the late fusion for us. Thus, a model is able to extract behavioral features from user text from different domains and also allows positive knowledge transfer to various different domains and applications as well. Thank you so much for listening to me. Uh, Please feel free to contact me at pralav@media.mit.edu. Thank you so much once again.